All right, so welcome everybody to the Java Legos Internet of Things session. We have, as you can see here from the desk, we have quite a lot of fun toys and things in store for you today. And I think the best analogy for today's presentation is it's kind of like a big theme park. So lots of fun rides, lots of excitement. Some of the rides are a little dangerous. So we have technology here. I don't know it's physically dangerous, but some of these could jump out and snap at you. And some of the things which we're gonna show you in our little Java embedded theme park today are the items you see up here. Now, can I invite the rest of my my co-conspirator presenters up on stage here? Come right around here. This is the Devox photo op time. Okay. So what I've done is I've taken, I have some of my own projects, and then these are my friends and peers, and we're going to show you some of the best of Java embedded in this one session at Devox. So you'll be getting a taste of Legos. We're gonna play with Lego Mindstorms and.
It's Lego, not Legos.
Okay, so the British gentleman
here. The British guy is correcting...
has corrected my English.
Right.
Is anyone from Denmark here? Is anyone from Denmark? Good. So you know it's Lego, not Legos.
Lego.
Legos, yes.
All right. So we will be playing with Lego. Lego. We'll be playing with Lego, and...
I think that's worse. I think that's an illicit drug. I think that's what it is. I think they're having fun with you.
Yeah. Thanks, Jim. All right, so we'll be doing some Mindstorms. No Lego. Mindstorms EV3, digital signage, playing around with Raspberry Pi, showing a bunch of different development boards which run Java. Some tips on how you'd pick a board, different boards, like very prototype stuff. We're going to show you the Duke Pad, which is a Java tablet, some telematics, so you can actually see what you can do with Java, hack together and homebrew for your car. And then we're going to close with some cool hackathon projects. So Vinicius, who's not here, will be coming back. Oh, there he is. Come up here. Come on. This is photo op time. You have to be in the shot. So Vinicius is going to come back here at the end and show some of the cool hackathon projects which they've been working out in the, at the tables outside. So we'll get to see like some of the great things which you've created over the past 2 days with your loyal hackers. Yeah. So that's just a little taste of what you're going to get to see in today's presentation. So, warnings, this is a theme park. It's going to be lots of fun, but you get to hold on because we have lots of crazy mechanical stuff flying around. And to kick it off, I'm going to invite Jim Weaver to give the initial presentation on Java and the Internet of Things to kind of set the stage for the presentation. So,
thank you. It was kind of cool how international this group is. So we've got Vinicius Senger from Ubatuba, Brazil. Of course, you're from the U.S., West Coast. I'm from the Midwest. Spanish from Colombia. Living in the United States.
Colombian passport.
With an Australian passport.
And it's really complicated.
And as we've noted, we've got this British snob here. Wait a second. He's also my boss now, so I can't really say British snob. Erase that from the tape. And then Gary Collins is from Santa Clara, California. So formerly East Coast. He was part of the East Coast gang, right? But now he's West Coast rapper.
Yeah, I've been morphed.
Gotcha. Okay. Right. Very good. Very good. Okay. Well, anyway, as Steve said, I'd like to just kind of start out by a quick IoT talk. I've got about 50, 60 slides that I'd like to bore you with here. Maybe 3.
I trimmed your deck down for you.
You trimmed it down?
That's
okay.
all good now.
All right. So what's really cool about this conference, I love this, is that as I point to things on the slides, I'm also pointing to body parts on that guy, right? Yeah. So I'm going to stand over here. I noticed you were doing that all morning, and Julia and I, my wife, were snickering at you.
Thank you.
Yeah, that was really good. So this first slide, really there's nothing new about installing sensors and devices. And I remember back in the 70s and 80s, how exciting it was to take my TRS-80 and hook up these home automation things where we could turn off and on devices and do sensors and things like that and kind of make stuff. And it was really great to attend the Globalcode, Vinicius and Senger's and others, the hackathon, Raspberry Pi hackathon, because in his talk he talked about how things are coming back, with Maker Faire, and we're just making stuff now, right? And we're making things for home automation and for other things, but there's one difference, and that is that because of Moore's law and because of the advancements in the internet and this Internet of Things, there's more devices now out there. There's more devices. Instead of being these dumb sensors, they're full-blown computers like Raspberry Pis and things like that, and there's a bunch more of them. So they're projecting by 2020 we'll have almost 7 devices per person connected on the internet, and those will be very, very powerful and smart devices. So rather than being in this mode of you've got a computer in the sky that monitors devices, we're moving more and more into this world where the intelligence is being pushed down into this Internet of Things, and the devices and computers that are hooked up to them are talking to each other, making decisions, maybe even in a few years, displaying the emergent kind of swarm behavior, making decisions in autonomous ways based upon things that they know about in cooperation with each other. So rather than this model, things connected to the internet, we're talking about this model, which is the Internet of Things. And so you can think of all sorts of different scenarios, right? In home automation or healthcare or shopping or environmental or food management or waste, resource management, things like that, to where smart devices and ones that have computers in them can cooperate together and really do good things, productive things on our behalf and of the environment. So one use case is there's a company by the name of Gemalto, and they make a tiny 3G enabled internet kind of device that has a Java computer on it, Java enabled computer on it, that then it's 3G enabled, so you can put these things different places and they can talk to each other with 3G. And so one way to leverage these, it's very tiny, one way to leverage these is there are some Gemalto devices in the Amazon rainforest embedded in trees. And so when bad people go chop down these trees and deforest, illegally deforest the rainforest, then these devices can tell and can communicate with each other and phone home and let people know that that's happening.
So if I had one of those Gemalto chips in my little Lego Duke there,
yes,
he might not have gotten stolen in San Francisco irreparably. Version 1 of him was in Angela's car the day after Java 1, or actually the afternoon after Java 1, and he was unfortunately stolen.
Absconded. Yes.
But if I had one of these Gemalto, 3G chips,
you would be able to track his.
You track it.
Yes, very good. Do I have any more slides, or did you take all my slides out of the deck?
No, I left you 1 or 2 more.
Did you?
Yeah.
So, as I've said, embedded programming is nothing new, right? We've been doing that for a long time. The things that have changed, I've mentioned one of them. One of them is that the devices are getting more powerful. You know, microprocessors, full-blown microprocessors, very powerful ones, are getting smaller and smaller, so they can be paired up with these devices and have, you know, millions of them, billions of them out there working on our behalf, cooperating with each other. Another fundamental thing that's changed is that it used to be so painful. I don't know, has anybody come from the world of embedded programming? Raise your hands. Anybody come from that world? Well, you can, I'll probably get an amen from some of you guys. You know, it is so fragmented. You're doing C, C++, you're doing cross-compiling, sometimes assembler. There are no real standards out there. Each board has different instruction sets. You're always worried about, you know, building a little framework or a testing framework. You're always building more than you have to, and to ensure some semblance of security, to be able to, for developers to really develop for this thing. You're always looking for new libraries, and then you know, you need to change the chipset, and then everything needs to change. So it's a very, very kind of painful, labor-intensive, time-intensive process. The fundamental thing that will help us move forward and make this really easy for us and really kind of make this happen as the number of devices scale up is the idea of using Java in these devices. So right now, if you look at Java SE7, on the right we see the language, and we see that with you know, with ME editions and things like that, the language is all the same, but the APIs, there's quite a bit of disparity between those. But if you go to the next slide with Java 8, the language is the same, but you can leverage a lot of the same APIs. There are some differences because you're talking about different kinds of devices, you know, interfacing with accelerometers, things like that. But then with future versions of Java, with the modularity, etc., then we're even getting closer, if you go to the next slide, to having that overlap be a lot more. So the point being that your experience in coding Java, your expertise in not only coding Java but the APIs around it, then can be, that you're using now for enterprise development and client development, translates very easy, and because the Java is really converging, makes it so that you can apply those same skills and leverage them directly in the embedded world. So if you go to the next slide, it kind of highlights what kind of pain you're avoiding by going to Java. So just, you know, pick a dimension here. Cross-platform, multi-architecture, Java embedded, yes. Native C, C++, it's all over the map. Think about security for a second. If you've got billions of devices out there that can monitor, make decisions for you, that can phone home, that can cooperate with each other, and you know, with sensitive information, you really, really, really want a secure model that you don't have to rely upon whoever is programming that particular device to adhere to. You want an overall security model, and that's one of the things that Java gives you with the APIs. Just another thing is performance, and another one would be field programmability, being able to update a program in the field. The last one, but not least, is developer community. You know, that's one thing we all have in common. We're all Java developers. So if we need to, you know, create a new type of device or create a new application for a particular device, because we know Java, we can do that rather than trying to, you know, find some expert in some particular chipset and particular, you know, C, C++ with a particular library and go through that. Can I get an amen from anybody? Amen? Amen? Thank you, thank you, thank you. So anyway, that's all I have to say. I hope all the demos go well. Steve?
Yeah, yeah. You
Yes.
want to introduce your IoT community?
Yes, oh, sorry. And one thing that we're launching is something called IoT Community Net. And what it is a place that will continue to expand in resources for the IoT community, pointing you at resources, also beginning to aggregate some blogs, so people that are blogging about IoT and things that are related, supplying a blog aggregation on the right side of that page, news and announcements, videos, things like that. And so please visit that. Also, if you're blogging about IoT, then please let me know. Send me an email. I'm james.weaver@oracle.com. I'm easy to find. Send me an email, and we'll add your blog to the aggregation. So,
Cool. Thank you very much for the
thank you.
great introduction, Jim. So I wanted to kind of set the context for what the future of the Internet of Things will bring, and overall what it means for the Java development community. A lot of the demonstrations we're going to show you today wouldn't have been possible without the new Java SE embedded support. So you can actually use Java SE on medium to large size devices leveraging the same skill sets used for Java EE and Java FX. And even the same open source frameworks and libraries and tools. There are folks running like Glassfish and full application servers on the Raspberry Pi, as an example. So there's a whole lot of capabilities for what you can do with the new Java SE support. And then also a lot of these smaller boards, you'd want to be using Java ME. And as Jim mentioned, there's a convergence going on starting with Java 8 and continuing to Java 9, where we're going to have similar language and APIs for both of those. So I'd like to reintroduce Angela Caicedo.
Hey, how are you?
Very good. So
Good.
we're gonna play with toys now because we
Java is a lot of fun, so that's the best part, having fun with technology.
we need a break from all this serious work. So one of the really cool things which happened recently, I still have my old RCX 1.0 Mindstorm set. Anybody else an old school? All right. So you guys are hardcore, hardcore Lego hackers. Actually, I think it picked up more popularity with the NXT because it was much more powerful, had better sensors, dedicated motor sensor ports, and gave you a lot more flexibility with the programming model. Also, there exists, and we're going to talk a little bit more about this. You have to help me on the pronunciation. Lejos?
Legos.
Lejos.
Legos. Well, I don't know. I'm Colombian. It's not very good to ask me.
If you look at the, I was trying to figure out the correct way to pronounce it. But lejos is there's actually a Spanish word.
That means far in Spanish.
Farm?
Far away.
Far away. Okay.
Lejos.
Lejos. So if you want to pronounce it in Spanish, you can do that. But I think also they don't mind people bastardizing and calling it lejos or something like that. So we'll call it lejos for the purpose of this demonstration. But what it works on all of these, but what really changed with the EV3, and this is why we're excited about it, is it actually has a ARM processor powerful enough to run full Java on it.
But it's not as powerful as the Raspberry Pi, is it?
No,
Yeah.
it's a little bit less powerful. So it's an ARM 9, 300 megahertz. The Pi is
ARM 11, so.
yeah, slightly faster processor. You don't want to do heavy computation on this poor little brick. But it does have some cool stuff. There's an analog to digital converter, which is really cool for hooking up sensors and devices. If you had a Raspberry Pi, you'd have to like breadboard and put your own analog to digital converter to hook up to devices. Also, it's got a really nice programming platform and then dedicated motor ports. They've added an additional motor port. The old NXT only had 3 motor ports. The EV3 has 4 now. 4 sensor ports, micro SD for expansion, lots of cool stuff. And we're going to talk a little bit about some of the sensors. So
So do you mind if I grab your Duke?
Yeah, why don't you grab Duke?
Okay.
Do you want to show something on Duke? I can camera it.
Yes, so
Okay. All right, so it's not exactly full screen, but it should be bigger than what you guys are able to see from your seats.
So we have the Duke, and I see that you have a bunch of sensors. So we have the motors, we have maybe light sensor, a touch sensor. Is there anything inside, Duke, that we can we kill this guy and open it up?
You know how much trouble we spent.
You don't want to
rebuild them.
destroy
Are you
it?
sure you wanna crack him open? So this guy actually, he's suffered severe brain damage. But I think, oh.
Yeah.
All
Okay,
right, so we've proven Duke does not have a brain. His head is empty.
So we do have a couple of things inside.
Yeah.
Besides that, it's falling apart. But okay, so I see that we have arms. So this is new. So we should be able also to have another motor controlling the arms. Good. And then I guess we cannot take more apart, right? So there's more stuff inside that we can maybe talk about it on the presentation.
The one thing you can't see inside of Duke is there's a gyroscope hiding in the center of the body, and that's how he does balancing on two wheels. So let's hop back, and maybe you can talk through this. Let's hop back, and maybe you can talk through the sensors.
Yeah, while you put this guy back together so it looks decent for the presentation.
I'll do surgery on this guy. And
so
see
we
if I can
have
repair
two
him.
motors, two kind of motors. The large one, it will be, more heavy duty. So that's the one we use for holding all the weight of the Duke. And then we have medium motors. That is the one that we're using for the arms. And then there is a whole bunch of different sensors that we love. So as Steve mentioned, so we have a gyroscope. So it actually allows us to measure angular acceleration. So we can actually detect if he's turning or if he's falling. He's actually going to fall, so we can move forward or backward to keep it stable and, avoiding falling down. It does still fall down a little bit, but it's pretty stable. It's pretty good. You can poke him, and we'll see how good he is.
He'll try to balance.
Yes, he tried to balance, the poor guy, but we keep bother him anyway. We have a touch sensor, and it is actually good because you have different modes, so you can actually detect when it's pressed, when it's released, or when it's bumped. So you actually have the 3 different modes. We do have a color and light sensor. So again, it's the one that we're using in the arm. And it's actually pretty cool because it not only detects colors, so I think we can actually detect 7 colors. But it also have, when we power it on, we can actually see that there is a red light coming out of the sensor. So we can do things like detecting the reflection of that light. So we can actually see if we are facing like a white surface or black surface. So we can actually program this guy to follow a black line or, make a boundary. So we make sure he doesn't go beyond those boundaries. So you can actually use the sensor to check the reflected light. And also the ambient light. So there are 3 different modes that you can use the same sensor. You can actually detect how far objects are, and for that you can actually use the ultrasonic sensor. So this is actually a nice sensor too, because it's not only sending sound waves, but it's also receiving. So it sends a sound wave, it will be reflected in the object back to the sensor, so he can actually measure how far the objects are.
One of the things to point out on the sensors and the EV3 kits. So if you go in a retail store, and if you buy the robotic EV3 kit that they sell in most Lego retail stores, then what you're getting is most of the sensors we're talking about, but certain ones like this ultrasonic sensor are not included, and they replace that with an infrared sensor that Angela will talk about in a sec. There's also a Lego education kit. So if you get the Lego education kit, you get the ultrasonic sensor, but you don't get the infrared sensor. And then there's some small differences, like it has a rechargeable battery pack, and then there's an expansion set with additional parts and projects to build. So they're both good sets, but if you're interested in hacking and you want a wider variety of sensors, the educational kit is fairly nice because It includes, like Angela was saying, this ultrasonic sensor, which is really good for distance detection, provides superior distance detection to the infrared, and also it has the gyroscope, which we're using inside of Duke to maintain balance. If you had the retail set, you would have to buy those in addition. You can buy all the parts separately from Lego for outrageous prices.
So besides just measuring, you can also detect if there is another infrared ultrasound sensor with you. So you have also, again, two modes. You can actually be sending sound wave and receiving, or just waiting and receiving them. So we can actually detect if there is another Duke next to yours, so stuff like that. So it's actually pretty good stuff to play with. We also have the infrared sensor, so we can actually also detect proximity using the lights, but for this one, we do not have an accurate measurement of how far the objects are. So we just get a value between 0 and 100. So the closer it gets closer to 0, the farther it is away, it's closer to 100, but again, it's not an accurate measurement as you can have with the previous sensor. And also, this one is pretty cool too, because also has two modes. One is the proximity and one is the beacon. So with the beacon mode, you're actually detecting if you have another infrared sensor with you. And you can actually detect where it is and how close it is. So you can actually, for example, create a Duke and play hide and seek. So when I detect you, I get far away from you and things like that. So, it's just a lot of fun that you can actually have with this bunch of sensors. We do have a remote control. I will see if we can actually, it has 5 basic buttons, and then you can actually have combination of those. So it's like 11 or 12 combinations of them. So, Steve, can you tell us a little bit about how to get started?
Yeah, so, the Mindstorms kits are lots of fun to play with, and, it's good practice to build some of the kits out of the box and get used to the construction and the programming of them. But if you're a real hacker, you're going to be coding Java on this. You're not going to deal with those stupid, drag and click and pull down drop boxes and tweak things to get normal looping and constraints, which is what you really want to hack, and you can do faster and easier in a real language. So what I'm going to quickly go through is how you would program your Lego Duke from scratch if you wanted to use Lehos and build out an SD card, build out all this stuff, and then program your device. So the basics are you're going to need some sort of micro SD card for storage. This is how you'll load the Linux operating system and then get all the software you need to execute the Java code and the Java distribution. A compatible Wi-Fi adapter. You can go to the Lego store and you can buy the very expensive official Wi-Fi adapter, or you could just buy what actually it's a Netgear WNA 1100, and it's much, much cheaper if you just buy it on eBay or Amazon or the equivalent here in Belgium. And the Edimax works as well, which is a very common one to use with Raspberry Pi or other embedded devices, and has a much smaller form factor. So that's what we have hanging on the side of Duke, is one of the Edimax Wi-Fi chips flashing in blue. And then you set up you also need to have a Linux VM on your machine to do a proper Lehos build and use the scripts they provide to set up your SD card. They're assuming that they tested it on, I think, Ubuntu 12, but any recent Linux distribution should be good enough to run the scripts out of the box. If you wanted to run on a different operating system, you would have to, did I advance? Yeah. You would have to hack the scripts and figure it out yourself from scratch. And there's a really good SourceForge site where they go through the full instructions for how to set up your SD card. So, if you have all these requirements, it shouldn't take more than an hour or two to set all this up. And actually, I fixed these little Dukes the evening before I flew out here to Europe. So I didn't have more than a few hours before my plane flight left. And I cracked 2 new SD cards because the old ones were stolen from my little buddy.
Again, and it's also handy. Once you get the SD card in, it's really hard to get it out. So keeping your nails long is actually become very useful.
I think pliers are the right way of ripping out that little SD card. It fits flush with the side of the case, which is cool, but it makes it hard to remove. Oh yeah, so for your IDE, if you want to actually compile the Lego source, they're Eclipse guys. So you need Eclipse Kepler to open their project and build it. But after that, you don't need to use Eclipse to build your projects. So once you have the EV3 classes.jar, you can use your favorite IDE, set up a NetBeans project or IntelliJ or whatever your favorite IDE is, and hack away, just including that as a dependent library. And then you want to get the same OpenJDK Java 7 runtime on your desktop computer as what they're using in the distribution. And there's a libjna file as well you need to build the source code, some other random things to pull together. And then I have the Git repo there for the EV3 source code to build it. Once they actually get a final distribution, I believe they're not final on the EV3 support. It's still like beta hacker type stuff, so they don't actually have easy download distributions packaged up yet. But eventually they'll get to the point where you just download and skip all of this build and set up steps when it's a little bit more stable. I heard that like this week or next week they're supposed to have a very big milestone release. So lots of stuff should be getting more stable and better for the Legos platform. Okay, so code. So this is a very, very simple Legos application. It imports the Legos libraries, first EV3 program, and then it has, draws a string on the LCD screen. So really, really, really simple. And they have really nice Java APIs for all the sensors on motors and things on the devices to access them. Angela and I were hacking the code yesterday, and we quickly switched the IR port and did some changes to it in the Java code. Once you're actually ready to run it on the device, you just copy the program over. The cards are set up where the root password is empty if you use the standard distribution. So copy the jar file over, go to the device, and then there's a JRun kind of wrapper class which puts stuff in there that you need, and then pass it your class path for your actual application, and then your main class, and you can run stuff on the Lego Mindstorms EV3. Okay, so let's give this a try and see if we can.
So this is your baby, right?
Yeah.
But how many women do we have in the audience? I didn't see that many. 1, 2, 3. Okay, so I have the good news. Can you just move, please? So we need to see more of the girls, so we have a Dukas. Right? So I have my own.
Yeah. No, that it wouldn't be fair to just have Duke without a Duchess. So this is gender balanced now.
Yes. So we see.
Okay. So we've got these guys powered on, and they get a IP address from the Wi-Fi router we have sitting up here on the table. Let's see, mine's 7, yours 6.
6. Yes.
Okay. And can I get because I need to do the computer stuff. Can I get a volunteer from the audience who is gonna, you'll do one, and we'll get somebody to help with the second Duke. Anyone want to try to do the Segway thing?
How about the guy that won the...
Yeah. All right.
Prize for winning
Hey, what's your name?
Jonas.
We'll try one more time. How you doing, Jonas?
Jonas. I'm good, thank you.
All right, here. So hold the mic for a sec, and I'm gonna describe how you get the Lego Duke running while I get the Duke running kick the program off. Let's see. Okay, so we're gonna SSH to the robots.
So that's me.
That's you. Okay, no password. And I've already copied over to the compiled classes to dist, and we can see here's our EV3 jar file, and just run him like that. Okay, so one guy should be started, and it's exactly the same thing. Boop, boop, boop. To start our second guy on 10.0.17. Try again. Okay. Denied. Is he turned on?
It is on. And we do have the IP address. Should I restart it?
No, leave him for a sec. Okay. So this guy's happy.
Yeah, girls are happy.
The girl's happy. And the boy...
I don't know about you guys, but...
Rude at... Okay. So, I think we should power cycle him, because he's unhappy. There's a special trick to power cycling these guys once they have the LHAAS software on it. The power off button no longer works. So the secret magical incantation is battery popping. Very, very effective. Thank you.
Yeah.
Okay.
Hold on, it's not totally in.
Booting him. Yep. Okay. Now he's starting up. Now, in general, these are not the fastest processors in the world, as I mentioned. They're even less powerful than the Raspberry Pi we'll show you in a sec. And the boot time off the SD card is even slower than booting off of the flash on the device, which is what you normally do when you boot up with the Lego software. So why don't we're all waiting for him to boot. Why don't we let him practice with yours and see if he can get one guy going, and then we'll add a second one.
Okay, did you start the program that I see the light?
So yes, the Duchess is started.
Yes.
And all right, so the way this works is to balance the robot, you press the button on his arm, and just don't move him, just press the button, and he'll start beeping like a time bomb. And then once he beeps,
And we all run.
immediately stand up the Duke.
Stand up. I'll leave it.
But then
like,
when he
don't move.
let go, oh, all right, excellent job, good job.
Now we can try to poke her. And it keeps the balance.
So basically the segue algorithm is kind of like a reverse pendulum. So whenever it sees, the gyroscope sees it's leaning, it will accelerate the motors and try to right it, and vice versa. And it has a couple of parameters both for the current angle and also the rate of change. So you can try to predict how fast you're falling to know when to speed up or when to slow down. And we have an IR. You want to... Okay, so basically the way the IR remote works is each time you click the button, it increments the counter and goes a little faster.
Oh, I see.
Yeah, so that's called a program bug. Yeah, so that's called a program bug. Each time you press one of the buttons, it goes a little bit faster. So just click it once or twice. That's turning left. So if you press that one, it'll turn left. That's turning right. And you want to kind of aim it for the sensor in the bottom. Okay, so hold on just a sec. Let me power cycle your program. I'm going to kill it.
You're going to kill it?
I'm going to restart your program.
Okay.
Because the IR sensor goes dead on the LHAAS. It's a known bug by these guys. Goes dead occasionally. This guy should be up now. Okay, now the second Duke is logged in. We're going to see if we can get them both running around at the same time now. Okay, so where's the second remote?
This is your remote.
Okay.
I'm going to give it back to you.
All right, so why don't you do the balancing of that one? I'll do the balancing of this one, and then you'll control one, I'll control one, and we'll
Okay.
get this working. All right, it's balance time.
Leave it steady now until it beeps. No, it crashes. Hold on. So once it starts beeping, you have to lift it and leave it straight. Now we're ready. Then we let it go.
All right, so 2 Dukies.
Let me see you. Maybe not. Maybe see you. Sorry, bye-bye. Sorry, I don't want to see you. Go back. Go.
This doesn't look
Oh!
good. All right, so just a quick example of what you can do with a couple Lego Mindstorms kits. And this is something fairly easy to build yourself. There's actually a Segway project in the education kit. So if you buy the core education kit, it comes with the Segway kit. And all this code is online, so you could try out the Lighthouse Segway program and make small modifications like powering the arm and changing the button and the color sensor behavior and doing different things with your Segway Duke. All right, so thank you very much.
Thank
You were
you.
a great guest. Give him a round of applause. Here, let me grab the mic. Got it? Okay, and we'll power off the Duke so we don't end up with a fried battery. Power off. Okay, so the next thing we wanted to talk a little about and show is it's actually a more powerful embedded processor, the Raspberry Pi, but it's actually much cheaper. How much does Lego?
The high end is like $35.
Okay, so for this,
Yes, for the high end. So
and
we
I think
also
it's also 35 euros, so that's not exactly fair, because euros are worth
Still
more than
pretty cheap.
dollars. But the Mindstorms kits are quite expensive, I
I think
think.
those are like $400.
How much do they cost in Europe? Anyone know offhand? The retail Mindstorms? $330? Yeah, so you could
US is
get about 10 Raspberry Pis for the same price as one Lego Mindstorms kit. So it's quite a nice hacking platform. Maybe build a little cluster of 10 Pis. And it has all the different ports and accessibility that you need to do a lot of small embedded projects. So you can use it just like a computer. It was actually designed by the Raspberry Pi Foundation in the UK for educational purposes. So it has HDMI and VGA out and USB and Ethernet and everything you need to actually work on it, plugged up to a TV and a keyboard. But it also has GPIO pins on it, which you can use to do all sorts of cool hardware hacky embedded stuff. Like what can you do with GPIO pins?
Well, I wanted to connect some nice gyroscope. So I actually found out this piece, the MPU 9150, and it's actually good because not only have the gyroscope, but it has an accelerometer, it has a temperature sensor, so it has a bunch of sensors in one single board, so it's actually pretty nice. Again, for the Raspberry Pi, so you have different options about which protocol to call, so it does support SPI and I2C. Particular for this one. And the good thing is, if you see the pins, so what we have here is the pins of the Raspberry Pi and how you actually can connect to your board. So the blue pins on the Raspberry Pi on this side are just the bus for data and for the clock, for the I2C. So you can actually connect this board pretty much directly. Normally you need pull-up resistors to get the data out of the buses, but the Raspberry Pi already have that. So it's pretty much, doing some soldering, but that's just a cable. So you have ground, you have SDA is the data channel, the clock, and you also have ED0. So that's actually allow you to have two of these guys together. So if you think about it, and the reason why I found this, so I wanted to play a little bit with the positioning of the device, right? So I have, before we have the Duke Pack that you're going to show, I have my own version of my Raspberry Pi pad.
The wooden
The first version was wooden, then it progressed a little bit like a metallic box, but it wasn't never as fancy as that. Mine has a hole in the back, which gave me really good access to the stuff, but of course it wasn't as fancy as that. So the reason for this particular board was, okay, so I have a gyroscope, so I can see angular acceleration, so I can actually see the tech when I'm, turning my device. But once I finish turning, there's no acceleration, right? So I did I did hear that we're moving, but once you stop, you don't have any angular acceleration. That's when the accelerometer come into picture, because when you have the accelerometer, you can actually detect the angle that you're doing against gravity. So once I flip the device, I don't get any signal from the gyroscope, but I get a reading from the accelerometer. So combining those two, I can actually figure out if I'm rotating, how fast I am rotating, and once I finish the rotation, okay, did I go back to position 0, or I'm still doing some sort of angle? So the combination of all that, I think it was very interesting in my case. And again, I only needed one, but you can connect 2 of these to the same I2C bus by either grounded or giving 3.3 voltage to the AD0. So you're basically changing the last bit of the address. So you can actually have 2 of these guys together. And again, I mean, you can just think, you have I2C, you have GPIO pins, so you can pretty much connect anything that you want to play with.
Yeah, so it's a lot more advanced than what you can do with a normal computer for small embedded devices. And so this, anyone who was in my last session isn't allowed to answer. But there's 2 ribbon cables on the top of the Raspberry Pi. Does anyone know what these 2 cables are for, or what these 2 connectors are for?
You're not allowed to answer, Simon. Come on.
Presenters are also excluded from the pool of folks. Just shout it out if you know what it's for, either one.
This one here in the front. Yes.
Yeah?
One
yeah,
is for
very
the
good.
camera, that's good guess. And the second one is?
Yes. All right, excellent. So the Pi Cam came out last March, and it's a really nice kind of pinpoint camera you can connect to the device, and I'll actually show you it on the back of the Duke Pad just now, because we happen to have one of these inside of the Duke Pad. There we go. Would you mind holding this up for me?
No, sure.
Yeah. Okay. So we'll get to all the other fun things in the Duke Pad in just a sec, but
It's right here.
yeah. So right in the center there. Maybe I'll get closer. You can see that we have a little pinpoint camera there with a ribbon attached to it, and that's the Pi camera. And it hooks up to the ribbon cable on top of the Raspberry Pi, and it's very inexpensive, and they've done lots of cool applications. Actually, Vinicius, who will drop by later, has built a real camera with like a button on it, and out of a Raspberry Pi plus a Pi camera. So he actually took it literally when they said Pi camera, which was red one? Infrared. Oh, I didn't know that. Okay. So our gadget master has told us that they sell an infrared version of the Raspberry Pi camera. That's very cool. I did not know that. Now, on the other hand, the touchscreen's not yet available. But what we use on the front of the Duke Pad, and I'm also showing here, which is a good device to play around with, is the Chalkboard Electronics touchscreen. Basically, what they do is they use a daughter board to interface with a standard LCD panel. I believe these are just standard Samsung overstock LCD panels. And they use a daughter board to interface with these to supply HDMI to the Raspberry Pi for display output, and then get back USB touch signals as well. So they can do the multi-touch over USB and then display out over HDMI, which is a nice hack. They have 10-inch versions and 7-inch versions. I believe the 7-inch versions, they were having manufacturing issues, but they should be shipping now. And the guys at Chalkalec have given us a little discount to give to folks. So you're in the exclusive club of folks who physically come to a presentation and can use the little code. So take a snapshot if you're interested in picking up one of the screens. And they're not that expensive. I think they're only $130.
Yeah, like $140.
$140 US, which is
the expensive
probably
thing is
cheaper.
actually the shipping, because it comes all the way from Malaysia.
Yeah,
so
they
the
ship
shipping is
from
kind
Malaysia.
of, for US it was $50, so I don't know how much it will be here, but that's kind of the issue.
Okay, so anyway, you can also plug up the Pi to a normal TV or monitor. You don't actually need a touchscreen. And to set up the Pi, it's really, really easy. So you can download the Noobs distribution, which the Raspberry Pi standard distribution actually comes with Java 7 pre-installed now. So you don't even need to download Java, although I would recommend getting the Java 8 early access since that has JavaFX support, and we like JavaFX a little bit.
I love it, yeah.
And I have the full instructions on my blog. I updated it post the noobs install and some of the changes which they've made, so it should be fairly up to date with the latest hoops you have to jump through, if there are any. There's a few small things you want to tweak in the settings once you get the Pi set up, like the split between the memory, the GPU memory, and the normal memory. Especially if you're running graphical applications, you probably want to give a lot more memory to the GPU. Also, tweaking the display size, tweaking the HDMI versus VGA, a lot of small things which will make it much, much easier for you to use the device and not get frustrated. But there are a few gotchas, which we didn't quite get time to finish for Java 8. So, no WebView.
Yeah.
And no media. Now, there's not an easy workaround for the former, for WebView. Basically, at some point they'll probably release a WebView component for doing browser and HTML content on embedded devices, but it really wasn't. Their prototypes really weren't up to the standards of what they wanted to release, so that's not going to go out yet. Media is a much more tricky case, although there is a nice workaround for that. So the way the JavaFX on Raspberry Pi works, it writes directly to the display buffer. And you can have multiple display buffers. So you can have a native display buffer behind JavaFX, which is playing video. And then you can have a transparent JavaFX application on top of it to simulate menus or other devices. And that's what we do on the Duke pad, I'll show you later, to play videos on the device from the JavaFX code. So it lets you put little controls and things on top of the video, just like you have for a TV or other appliances and devices which have UIs, but then takes full advantage of the hardware accelerated media support on the device since you're calling native media layers. Okay. And you can do cool stuff like anybody check out the signage outside the doors? Walking around the room signage? So what do you think? Is it pretty good? So this is the room signage designer this year was Angela.
So the good thing is those screens are powered by the Raspberry Pi, and doing things like this are actually pretty simple. Again, it's just pure. Things like this are actually pretty simple. Again, it's just pure JavaFX. For the design, what happened? Okay, for the design, I use Scene Builder. So it's actually pretty simple. I just get the idea of what I want to do with any, I normally use Photoshop. I design what I want to do. I take a scene builder and allow me to easily drag and drop and place the components exactly what I wanted. And then if there is something that I cannot really place because I need like a runtime information like the speakers, I need to know, depending on the session, how many speakers there is going to be. So what I cannot do, and what I ended up doing, is just placing a placeholder. So, for example, I wanted to render the speakers in a vertical positioning, so all I do is I get a VBox that is going to be the container for the speakers, and from my code, I just populate them with the correct information. So, I love Scene Builder. I think is a great tool for putting together really easy.
I have like a brother.
Well, yes, we have this theory in the team. When we try to figure out when does Steve sleep, we just, each day has 24 hours for each of us, but you get so much done that we came to a conclusion there is not just one Steve, there is 3 Steves. So there's one that stay at home, one that travel, and the other one is, what, creating content maybe? In the office. So yeah, so that's our theory. There's no one Steve, this is just one of them, so that's why I put 2 of you there.
Yeah, one of them's more handsome than the other 2, apparently. Okay, so I mean, it's really cool that this year we actually did the full signage and like FXML is a GUI builder tool, which last year, if you remember the space signage, that was actually just hand-coded JavaFX, and it was fairly hard to maintain. This, we got last-minute requirements from Stefan. He's like, Devox logo, not in the corner. I want it to be centered, and we had to move it around for him. And then, you know, the room signage, we had to hack together like BOF rooms this year. Last year we only did session rooms upstairs, but then we added the BOF rooms this year, so we had to like hack the code, and that was fairly easy to do. So it makes it really easy and clean to separate your UI from the actual code. And it's probably the most interesting bit of code that glues all this together is the controller class here. The controller class is what lets you synchronize the code which you're doing in Scene Builder with the Java code that's actually running and doing the real behavior inside of the IDE.
So right now it looks pretty, a lot of labels, and normally you don't have, so what happens is normally if you have to modify anything from those components, let's say for example I want to add speakers and all that, I inject a container so I have access to that container, right? So pretty much I will have access to the title, the abstract, and the time, and that's it. Here, because I have so many labels, and the reason for that, I wanted to use specific font. So I actually have to take each label and just set the font manually. But otherwise, is you just inject the components that you want to have, then modify some source. Anyway, so it's actually pretty clean, just put in some of the fonts, and it's very straightforward, and the rest is just Java connecting to...
Yeah, no, it simplifies the code a lot. And you can do bidirectional communication. So the add_fxml means it's getting injected for variables, but if it's a method, you can call the method from your fxml code. And even though I opened the fxml in the WYSIWYG scene builder tool, who likes hacking pure XML? All right, so Johan, some guys in the back, you're hardcore XML hackers, yeah? No stupid tools. So you can make changes right here to the directly to the fxml file, which gives you kind of that level of confidence that Scene Builder is not messing with your UI and your model. You can actually go and make changes and see what's happening under the covers. So let's see if it works. It works outside the door, so I hope it works on my computer. So actually, the slowest. Anyone want to guess what the slowest part of the? Stefan's going to kill me for talking about this. Anyone want to guess what the slowest part of the application is? What takes the longest in the startup time? You can see it's fetching data, doing stuff. All right, so let's give you some choices. Do you think it's like parsing the JSON, constructing the UI, or waiting for the Devox web service?
He's here.
Oh, all right. Now he's going to really get me. Hey, Stefan. So all right. To give the Devox crew credit, they actually have a version 2 API, which is much better. And I've been told that if we coded this against the version 2 API, it would be lightning fast. So that's what we'll do next year, and it'll improve startup time. And actually, what we did, since you can't rely on internet connection here, is Johan and I did a little weekend hack session, and we coded it for offline access. So if you don't have access to internet connection and you want to boot up the application without actually having it live, there we actually got some data back. Then what you can do is you can run it entirely in offline mode, and it will just read the last cached values and open up the user interface, which is really cool. All right, so we've got exactly the same UI as what you can see on the Devox. I can make my monitor resolution bigger if you wanted to see it, but I think actually that is the current time, 2:30. And apparently we picked the wrong room because that's not us.
Yeah, that's not us, yes. That's a good point.
But it's configurable. You can pass into the program exactly what you want to run. So, since we're doing signage on the Pi, this is probably a good time to show you how to deploy to the Raspberry Pi. So I happen to have one of these Pi thingies with me. This one happens to be in a aluminum case, which makes for a great heat sink. If you come up during the break or at the end of the presentation, you can touch the Raspberry Pi and it's visibly warm. Kind of makes you scared if you put your Pi in a little plastic case, how hot it gets. But the Pis actually run fairly cool. If you keep them at the default clock speed of 700 megahertz, then you should have no problems with overheating in standard Pi cases. But if you overclock it, all bets are off. So my recommendation would be do not overclock your Raspberry Pi if you want to have it work. Okay, so Pi. Now I'm going to hook it up to the same guy I used before. We got a little VGA capture dude. And I committed faux pas number 1 of starting up a Pi. If you don't hook up the Pi HDMI before you hook up power, it defaults to the VGA port. You can change the settings in the boot script, but it's a little bit annoying that it defaults to probably the port which is least often used, the VGA one, but I think that's because they can't detect signals on that. And then we've got the Raspberry Pi user interface up. So, gentleman in the back of the room, font's good size, yeah? All right. Yeah, so it might be a little hard to read the small text, but we can perhaps fix that. Rather than doing stuff on the command prompt here, we're gonna switch over and do stuff. Okay, I think I'm internet sharing. Terminal. Your pro tip of the day: apt-a or apt- what is it? ARP-a lists all the devices on your network and does not list my Pi because I'm not internet sharing. Okay. Oh, wait. No, I got more devices there. So I think I am internet sharing. Yes, I am internet sharing. Okay, so it looks like he's on 12 again. All right, and now we're hooked up to the Raspberry Pi. Okay, so I've got some stuff here, but I do not have our new signage app, which is unfortunate because we want to run signage on the Raspberry Pi. So you can either compile on the Pi, and it's painfully slow, or you can just compile on desktop and use exactly the same binaries on the Raspberry Pi because it's compatible. The Java SE versions are compatible between different versions. So you can use it on Mac, Linux, Windows, or ARM with exactly the same binaries. I typed that wrong. And then we're going to hook up via SFTP, get access to that guy, drop in and find our NetBeans project, which I wish I knew where it was. Where are you? Users, SJC, Devox. There you are. Okay, so we got a little dude, and we're gonna copy him over to devox.jar. Is there anything else I need? Is everything in the jar file?
Nope.
Should be, right?
That should be it.
All right. And let's check what Java version I'm running here. Java 1.8 early access build 106. I'm a little outdated, which might be a problem, but we're going to give it a try anyway. Okay, so I'm just running a normal Java command to kick off the JavaFX application on the Raspberry Pi. What we're seeing here is the output from the console. So we'll see the same process of fetching data and then getting speakers back on here. But then if we switch over to the screen with the horribly small text, then this will actually show us the graphical output because this is the frame buffer for the Raspberry Pi coming out of DVI. Oh, and it's slightly faster the second time than the first time, so that's good. Maybe there's actually a cache in the background there somewhere, caching stuff. So this is an excellent time to ask questions about Raspberry Pi before we move on to the next topic. Does anyone have questions? And we have a microphone up front, or there's one there, and there's No, I think there's just one microphone there. So if you have any questions, hop up to the microphone, or we'll run a microphone up to you. Oh, maybe we have output. Ooh, yes.
Yeah.
Okay. So, same application running with visuals on the Raspberry Pi. And it's very, very easy to swap between desktop and embedded deployments. So this makes it, super simple. You can build apps using Scene Builder. You can deploy to desktop or the Raspberry Pi, and it's all very, very simple to do. All right. So please give my co-presenter Angela a big round of applause.
Thank you. Thank you very much.
So the next thing we're going to do is we're going to talk a little bit about a real industrial use case for the Raspberry Pi. No, not you yet. So I asked one of my friends on the DevOps program committee who actually runs a company and works on embedded devices and stuff to come here and show us a live use case for what you can do with Raspberry Pi and sensors and NFC. So we're going to go through the short use case of what you can actually do with the Raspberry Pi for real companies and projects which you might have for your clients. And then we're going to take a short break after that. But first, I'd like to introduce Johan Voss. Welcome.
Hi, Steve.
All right, big round of applause to one of our DevOps crew members. He's the reason you have all the nice. What did you do this year?
Sorry.
Signage.
I was enjoying the applause. Okay, so so far this has been a fun session. We're done with the fun now. Because until now, these were Oracle speakers. Now everybody knows Oracle is a fun company, flexible. They do lots of funny things. Unfortunately, I work for a company that does more boring things, less fun at work and so. But I can show you something that, that happens in real business.
Okay, yeah, not like those fakey, demo-y stuff, right?
No, the signage is my boss is not allowed to know that I worked on some fun project because we don't do fun in Belgium. It's probably only Oracle that can do fun projects. You want me to show it?
Yeah, no,
You
I'd
have a
love
slide?
to see it.
Oh,
I love to
you have
see
my slides.
Yeah, a couple.
Wait, did you remove my animations? I had lots of animations on the slide.
We couldn't have your animations competing with our great graphics, so I had to cut it down to just text.
Actually, you didn't even say that I did the minor UI tweaks on the digital signage. But you can confirm that it's true.
So I believe this is the first time Mr. Voss has created a perfectly pixel-aligned user interface.
I also think it's going to be the last time. Okay, so the Uitpas project. For those of you in Belgium, you might know Cultuurnet Vlaanderen. Who of you knows Cultuurnet? Okay, so a few people that at least care about culture in Flanders. So the others are also very cultural, probably. So Cultuurnet Vlaanderen is a government organization trying to promote cultural events in Flanders. And one of the projects that they have is the Uitpas project. You might have heard from it. It has different names. There's commercials on the radio, Vlieg, Culture Feed, UTD. I've got all the names, but they make promotion about it. And they do that together with local communities where they want to attract people to local cultural events, regardless of their financial status. So they have this concept called the Uitpas, which is an NFC card. You will have here the MyFair Classic, but they also have the ultra light ones, which is more or less the same than the Devox one. People receive or can buy such a card, and they can then go to cultural events, and they can then check in for those events. And check-in happens with one of those kiosks that you see here. Next slide, please.
No, I can only do that for Jim, not you.
No. Next slide, without the please. So those of you who know Larry Ellison, it's his, I think he's your direct boss, or there might be 1 or 2 levels between.
Yeah, as many levels as I can get, yes.
Integer.maxint.
Yeah.
So he never says please, he always says next slide, probably to you as well. So what do we have for our hardware? We have a Raspberry Pi, the same thing as Steve showed, with an NFC reader, which is the ACR122U. We have an S-Video screen. Actually, this some guy at the Cultuurnet who assembled it together. So it's actually a screen, a monitor for in the car, but you can attach it to the Pi as well. And I can maybe show the back of this. DukePad is on top of the cable. Can't touch it. So, do you see this? Yeah, more or less. So we have the Pi here with the SD card. Here you see the card reader, the NFC reader.
Turn a little to the right.
To the right.
Towards the camera. Yeah,
So
perfect.
here, okay. Yeah, but right for me might be left for you. And the screen is, I think it's always confusing when a camera says go to the left, and we had this discussion before. Here we attach the S-Video screen. Now I have to turn it again, because here you see the screen. And so this is the hardware setup. So they have a number of those kiosk devices that they put in cultural places. For example, is there someone from who knows the Cultureel Centrum De Werf in Aalst? Well, there they are supposed to have these devices. So if you go there, you can check in. How does check-in happens? Did I have these cards? Yeah, I'll show that later because, next slide. You have more things to show than me, so I have time. Next slide, please, Mr. Chin.
Software or
Software. Oh, that's the next already. How do you go to the next slide?
That's why I'm here, because you're one of the finicky presenters. You click, 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 and the guy in the back is like, no, you just meant one. That's me.
Can I also ask next explanation, or no? I have to do it myself.
No, you do it yourself.
So the software. So this is actually hardware and software engineered to work together, from a small company in Belgium called Lojon. Is there another company with that slogan?
No, I
think
don't
so.
know a company like that.
So we started with Java 7 for ARM Early Access. Was released last year in December. Worked fine, but meanwhile we upgraded to Java 8 Early Access. I think we're at build 112, but yeah, we occasionally upgrade them. The interface with the NFC reader, and that's actually something that many people don't use, but in the Java SE, there's a package called javax.smartcard.io, and that does all the interfacing with the, thank you, Steve, with the NFC reader. So we don't have to send bits for reading the chips. It's just a Java API that you can use. And for connecting to the backend, because if you swipe your card, there was going to be a call to the backend. We use DataFX for this. So DataFX is a cool library for Java FX for connecting your Java FX application with real-world backends. So it can make REST calls, process the result of the incoming XML or JSON, and render it in a list view or whatever, because it makes use of the observable classes in Java FX. Next slide, please, Mr. Chin. So, well, I'm really glad that this is the last slide, because I really don't know what else I had to do for making this guy turn the next slide. Typically, I only make fun of Jim Weaver, but since he's not presenting today, I have to make fun of this guy. So, how's the flow of this application going? When we start the application, first the card readers are detected. That's done with a javax.microcard.io package. We ask the backend which event do we have, how does it happen. Each of these kiosks are equipped with a configuration file which mentions a unique identifier. Then we use DataFX to make a REST call to the backend, and the backend knows it's this time, so it's the current time actually, And it is this device that's going to ask information. It looks up and it says, okay, in this theater is currently this movie, so we will feed this information to the device. The device then shows it. And from that moment on, you can swipe your card. And that's for people that come to the event. They swipe their card. Their card has a unique chip ID that's sent to the backend. It is validated whether this user is allowed to check in for this event, or if there's a problem, it's being mentioned, and then it's rendered. So maybe I can show it. Don't zoom in too. So the goal is not that the viewers or afterwards on Palais can see what's mentioned here, because it currently mentions probleem met event. And that means everything is ready. No, that actually means, so we're not wired here, so we don't have Ethernet, so we're not going to get real-world data. Another reason for this is that I think this kiosk is connected to the production system running at Cultuurnet. So they don't even know, I think, that I took this. Well, actually, it was my colleague who brought it here. So we're going to swipe a card, but you will see that this red light is going to turn green. And for those of you in the first 55 rows probably heard the beep, which means it's scanned. And now you see it mentions something different. I'll try to do that again. Network unreachable problem. Try again in a few minutes, or you can't read the card, I was too fast. Or warn an operator. So that's what occasionally these things, they lose their connectivity. So then we print different messages. What's extremely important here, if you do an application like this, that is threading. Because this is, you don't want to block your output when the network is unreachable. So you really have to make sure that the threading is right. And there, JavaFX is excellent, because you have the worker and the tasks and the service classes in interfaces, which are part of the JavaFX concurrent package, and you definitely should use this if you work on the embedded devices. In summary, JavaFX and Java 8 on the Raspberry Pi allow you to create not only fun applications, but also business applications. And with this, I think it's time to go back to the fun applications.
All right, thank you very much, Dr. Voss.
You're very welcome.
All right, so with that, we are going to go on a 15-minute break. So after the break, Gary Collins will join us to go through development boards. We'll show the Duke pad. We'll have telematics, lots of other fun in store. But please enjoy the break and get a rest. See you in 15.